Hi, I'm Phil Vashurin from Right Maths, and today I want to talk about moments. Well, I've written in the box at the bottom that the moment of a force about a point is equal to the force times the perpendicular distance to the line of action of the force. Well, just to make that a little bit simpler, I'm going to call the moment m, the force F, and the perpendicular distance d. We now see that the moment is equal to the force times the distance. Well, that's much simpler. We have to be a little bit careful though, because in some cases, the force and the distance that is shown are not perpendicular. The perpendicular distance in this case between the force and the point D is d sine theta. We can do that with simple trigonometry. So the moment in this case is the force times the perpendicular distance, which is d sine theta. So you may need to be careful when you work out the perpendicular distances. In A-level questions, there are some things that I need to bring to your attention. The word equilibrium, or the words at rest, means that the moments at any point sum to zero. In other words, you can do a moment balance. Secondly, the total resultant force on the system is zero, so you can also do a force balance. The second point is that the weight of any object can be regarded as a single force acting through the center of mass. This is very useful. For A-level questions, we generally are working with forces on a beam. The forces are all in a vertical direction, and so the perpendicular distances are just the distances along the beam. Here's the first question then. We've got a plank, AB. It's 2.4 meters long, and there's a weight of 8 kilograms attached to the plank at C. The distance to it is 0.8 meters, and we're also told that the weight of the plank is 12 kilograms. And there are two inextensible strings at A and B which are holding the plank up. I'm going to mark the forces onto the diagram because they're not shown in the question. So we've got a tension TA in the string at A and TB in the string at B. We've also got 8 kilograms at C. I'm writing 8 times G because we need to multiply gravity, and the mass of the beam is 12 kilograms, so I'm writing 12G now. We can represent this 12G as a single force acting at the center of the group beam, which is 1.2 meters from the end. I've simplified everything onto a diagram here, and now I'm in a position to take a moment balance. We're told the system is in equilibrium, so we know that the clockwise moment must be equal to the anti-clockwise moment. So let's take moments about A. Well, which forces give the clockwise moments? Well, it's the hg and the 12g, so let's work out the moments. Force times distance, so we've got 8g times 0.8 and 12g times 1.2, and that must equal the anti-clockwise moment, which is the tension at B times 2.4. Let's work those out. It's 6.4g plus 14.4g, and that must equal 2.4 times the tension at B. So the tension at B is equal to 20.8g over 2.4, which if you use a calculator comes out as 26 over 3g. And if you want to work that out, it's 84.9 newtons. And I've taken G to be 9.8 meters per second squared. But the paper may tell you to use 10 meters per second squared. Do be careful about that. In part B then, in the question, we're told that the plank is now non-uniform and the tension in the ropes at A are 10 newtons greater than the tension at B. So the tension at A is tension at B plus 10, or TB plus 10. The beam is non-uniform, which also means the center of mass is not known. So I'll mark it as X meters along the beam. So now we've got two unknowns. We've got TB and we've also got the X. So we're going to need two equations. Well, I can get one equation from a force balance, which means that the forces up must be equal to the forces down. The forces we can see are TB plus 10 and another TB, so that's two lots of TB plus 10. And they must equal the forces down, which are HG and 12G, or together 20G. Well, if you work all that lot out, you'll find that TB is 93 newtons, and that's taking G as 9.8. So now we can get a second equation by taking moments about A again. So the clockwise moments are from the forces of Hg and 12G, and we times these by the distances to A. So we've got Hg times 0.8 plus 12G times X, which must be equal to the tension at B, which is 93 times 2.4. So if you work all that out, you'll find that X is 1.36 meters. Well, thank you very much for watching. I hope you enjoyed it. If you did, then please subscribe to my channel and also have a look at rightmaths.com, which is my website. Thank you very much.